Avengers Endgame. By this point, I'm sure you all have heard of it. It was by far the most popular film of 2019, and it's become one of the highest grossing films of all time if you don't adjust for inflation. I went to see it myself the night it premiered, and I absolutely loved it. But in the weeks after I saw the movie, there was just one little flaw about it that stuck with me. I just couldn't stop thinking about it. It was nagging me. It haunted every waking moment of my life for a month or so, and basically there was just this one thing that bothered me about the movie. Spoiler warning if you haven't seen the movie yet. Towards the end of the movie, the big three, Tony Stark, Steve Rogers, and Thor, face off with Thanos head-to-head in this really intense battle. And at the beginning of the fight, Tony fires this cluster of lasers at Thanos. So Thanos sees this, and instead of, ducking behind cover or maybe picking up something really big to block the lasers, he just starts spinning his sword really fast. And therein lies our problem. Lasers are light. They're the fastest thing in existence. So this brings us to the million-dollar question. If Thanos' sword is really blocking all of the lasers, how fast is his sword spinning? Now, the speed depends on how big the sword is, so we first need to calculate the size of the sword. Using this shot from the fight, and knowing that Steve is 6 feet 1 inch, we can figure out that the sword is about 7.5 feet long and 9 inches wide. Then, using this shot, we can find that the sword is about 3 inches thick. We also need to know the radius of the ring of lasers, and using this very high-resolution shot that I pulled from YouTube, I found that this was about 2 feet wide. So now we can start doing some math. Let's say that Thanos' sword just kind of deletes all the light that it passes through whenever it goes through the laser. This means that the sword has to spin almost 180 degrees in the same time that it takes the lasers to travel 3 inches. And the specific speed that this comes out to is 1.14 times 10 to the 10 radians per second, which is around 300 million RPM. Now, you can probably already tell that that's a huge number, but let's put that in perspective. The tips of this sword would have to move at 29.6 billion miles per hour, which is more than 44 times the speed of light. If you modified the sword so that it worked kind of like a fishing reel, and you attach one end of a fishing line to the reel and put the other end on Mars, Thanos could reel in the entire line in about 4 seconds. So these statistics are pretty insane, but we can go even deeper. The rotational energy of the sword is given by this equation here. We already know omega, because we just found it, so we just need to find I, the moment of inertia of the sword. And to find that, we need to solve this equation, so we need to know the mass of the sword. Now, we don't know the exact material that the sword is made of, but the general consensus from online is that it's made of this material called Uru, which is the same material that Thor's hammer is made of. And we don't have an official number for the density of Uru, but I was actually able to find this officially licensed Thor trading card, which very conveniently has both the weight and dimensions of Thor's hammer. So, blah blah blah, math happens. The density of Uru is 1.22 grams per cubic centimeter, which is actually 6.5 times less dense than iron. So, yeah, the more you know. We can combine this with the sword's volume to get the mass, plug that in to get I, plug that in to get the kinetic energy, which comes out to 1.46 sextillion joules. Okay, how much energy is that? The amount of energy that's released in a nuclear bomb explosion is about 75 trillion joules. So, to equal the amount of kinetic energy that's stored in Thanos' spinning sword, you would need over 19 million nuclear bomb detonations. That amount of energy is also equal to 405 trillion kilowatt hours. The entire United States consumes about 3.9 trillion kilowatt hours of electricity over a whole year, and the entire world consumes about 22 trillion kilowatt hours of electricity over a whole year. So, let me just reword that. The amount of energy stored in this sword, at this moment, could power the entire world for almost 19 years. If you hooked Thanos' sword up in this moment to a perfectly efficient generator, and you just slowly pulled energy out of it, you could use this sword as the world's sole source of power for almost 2 decades.
But I'm not done yet!
Thanos spins his sword up to this speed in 7 frames of 30 FPS video, which is just under a quarter of a second. So, the power output of Thanos' wrist, or whatever machine he's using to spin up the sword, is about 6.3 sextillion watts. The average nuclear power plant has a power output of about 1 billion watts, and the power output of Earth's core through heat is about 44 trillion watts. If you took the core out of the Earth, and you put it in a kind of heat Dyson sphere, and you did that 144 million times, those 144 million cores would still produce energy more slowly when combined than Thanos' wrist. So yeah, Thanos' wrist, is able to either produce or channel an impossible amount of energy, and it can accelerate things to 44 times the speed of light.